Hey everybody. As you probably have seen in the title, I'm trying to create a DIY oxygen generator, and I'm using electrolysis of water to do that. I'm not going to get too deep into the chemistry of it or the workings of it. I'm basically making this video just for the build. I have another video that's coming out. I'm still editing it. I can't find the time to finish that, and that's why I thought I'd quickly share this with you because I have some complexities and I need some advice. Right? You see this purple blue uh, substance here? That's something that I really want to discuss with you about. So quickly running through the build. What I have is, like you can see, these are two pop bottles. I have a container. It's a 15-liter container that I filled up to the 10-liter level with water. In my water, I mixed sodium hydroxide, right? Sodium hydroxide is a very good, uh, uh, you know, substance that you can mix with your water to make a good aqueous solution for for electrolysis. It's good because if you use something else, you might get some weird gases. Sodium hydroxide, you don't have the danger. You always form hydrogen and oxygen. This can be confusing for a few of you if you're not familiar with the electrolysis. Um, I'm going to explain electrolysis later. Sorry, I'm not doing that in this video. This is just so that people can advise me and so that I can share my build. I'm looking for feedback. That's what this is for. Um, so these two pop bottles, and then I've got my stainless steel wires coming into these pop bottles. Everything sealed off. All openings of these bottles are sealed off using a silicone sealant. The stainless steel is because stainless steel is an okay conductor of electricity, but it doesn't form oxides, right? So what I've done is I've basically coiled up my stainless steel around a conductor so that I increase the surface area, like you can see here. And good, like you need good surface interaction between your electrode and your electrolytic solution. Uh, and in addition to that, what I've done to increase the surface interaction even more is I've used stainless steel wool, right? And this I think is where I don't think it was a good idea because it's forming some weird oxides. That color I think is I think it's chromium oxide. The stainless steel has chromium, but again, you need a lot of temperature for chromium to form an oxide. I don't know what it is, but we'll get to that in a minute. And that's something that I'm having trouble with. You could also use something that's widely available, stainless steel rulers, as your electrode. I didn't try it yet, but that's an idea. Another thing is graphite. What I've done is I've pulled graphite out of a AA battery. I don't recommend this because you don't get a lot of electrode material from a AA battery. Uh, for this, you probably need like 30 AA batteries that are used. Waste of time, and yeah, and it's a little dangerous as well. Got to be very careful when you open your batteries and make sure that you don't get your fingers um, in contact with that. Always wear gloves. um, these are nitrile gloves, so they and one more thing, NaOH, sodium hydroxide, is acidic, right? So you don't want that on your fingers or on your eyes or anything like that as well. It's basically used as drain cleaner as well. It's yeah. Don't mess with this stuff. Make sure that you're safe. Since we're talking about safety, I'm using nitrile gloves. Earlier, I used cut-proof gloves to when I was using sharp objects. I know that there's electricity here, which I'll get into a minute. But yeah, so be careful with that. I'm wearing safety shoes. Make sure that you have safety shoes. You've got gases coming in. Both the gases that are coming out are highly combustible, oxygen and hydrogen. So be careful of all of this. Work in a well ventilated area. And one more thing is make sure that your container is not leaking, right? You don't want a leaky container. That'll have acid all over your tabletop or your floor. So again, be careful. Anyway, so I've got that. I've got a converter here. So this converts my alternating current that's coming in from here to direct current, right? And this one's 12 volts and 8.5 ampere hours. Think of it as a car battery, right? So because the car battery is also 12 volts, this is, I'm using this just to show you that you can do this whole thing even using a car battery. The system is on. You can see those bubbles forming there. That's our hydrogen forming. See some bubbles forming here. That's the oxygen, right? What I've done is I've got these vinyl tubes coming out of my used pop bottles. From the cathode, you can see that there's hydrogen coming. Taking the hydrogen and I'm feeding it to a soap solution. So you can see it's collecting okay. But if you're familiar with electrolysis, you know that hydrogen's almost twice the amount of oxygen. The production of hydrogen is twice the volume of your oxygen production. Let's actually do a quick test. It's a lighter. Let's see if it pops. There you go. So you've got a pop. You know that it's hydrogen. It's another reminder. Be careful. Always work in a well-ventilated area if you're working with gases. So now getting to my oxygen, which is the real reason we're conducting this experiment. It's the oxygen is being produced, like you can see, but most of the oxygen is reacting with something and it's forming an oxide, right? And that's why I see this sort of a purple halo around my my anode. So that's something that I'm worried about. I think if you have any suggestions, please help me out here. If you know what that is, maybe it's just the bad stainless steel wool. It's got some other substance, not just stainless steel, or it's just the chromium in the stainless steel that's reacting with the oxygen that's being produced, and that's why my oxygen, all that's being produced, it's being consumed for the oxidation, and that's not desired, right? So that's about this. One other thing that I think I've noticed is that I don't need this much of equipment. 10 liters, 1 liter of liquid water can give you over 600 liters of oxygen at atmospheric pressure. So you don't need this much water really. What I do next time is probably I'll just use the pop bottles, get rid of the container, don't need this. And I won't cut open my pop bottles like I cut them open here. What I'm going to do instead is I'm basically going to connect both of them using a vinyl tube, right? That's for ionic transfer. And then the rest, I'm just going to do the same, anode, cathode, and 2 vinyl tubes coming out of them. This makes it compact, obviously. And the other thing it does is it also helps me to build more of these units, and then I could cascade them. So this is one set, right? This is one set, and let's say I'm getting a quarter of a liter of oxygen per minute, which is overreaching, but let's just say that I'm getting that much from one of these units. What I could do is I could cascade these and have, like, let's say 5 units. Then I'm getting 5 times that. So then we're getting into numbers that you can supply with a good confidence that you're doing some help there. 2 liters per minute or more is what you need for medical grade oxygen. So that's that. And again, if I'm cascading them, what I do is I connect my tubes, right? Like all the anodes would have tubes coming out of them. I'll connect all those tubes, and that will be my oxygen exhaust. And then if I connect all the cathodes together, like all the output tubes together, that would be my hydrogen exhaust. That's an idea. I still have to work on the heating aspect. Stainless steel heats up real fast, right? Have to work on the heat dissipation. Obviously need to work this thing out, and I need to work on the it's a little bulky right now. Just need to make the system smaller. So yeah, if you have any ideas, definitely please let me know. I'd be interested. um yeah, yeah, help me out here. And all right, thank you.